Alright, so we're going to try to learn here Lewis structures. It's a relatively important skill in their chemistry skill set because it allows you to figure out how different atoms will be connected to each other to form their molecules. Now, it doesn't give you any information about 3D structure, but it does tell you what's going to be connected to what. So, there's a base assumption always when you're talking about Lewis structures, and that's whatever formula you get, they're connected together. And so you're going to have to connect these things together. I'm going to teach you here a foolproof complete method. Now, what this means is that this method, you don't have to know anything about this compound. You don't have to make any assumptions. You just follow this method, you'll get it right every time. Great. It's a wonderful thing. And this is the sort of method that is perfect for when you've studied all night and you need to do this off of 1 or 2 hours of sleep. You always get it right. You just need to follow the method. All right, so the first thing you always need to do is you either need a periodic table or you need to know the periodic table well enough that you can figure out what group is what. Because the big thing here is actually groups. Now, I've given you a bit of a hint here, and that's that connectivity is going to be bonding, right? We're really talking about what's bonded to what. And so the periodic table has these things that are called groups. And these groups are labeled up here. So right here we have 4A, 5A, 6A, 7A, 8A. And these groups are going to tell you how many electrons are in that valence shell. Now, the valence shell, those are the electrons on the outside that are going to interact. Those are the ones that are going to form bonds. And so those groups really are how things bond together, how they chemically react. And that's why the things in groups have very, very similar chemical properties, because they literally have similar outer shells. The part that interacts is very, very similar. It has 4 electrons in all these cases. So we have here our chemical formula, CH4. The first thing we need to do is we need to figure out how many valence electrons are going to be interacting. Because if you have $10,000 in your account versus $10 in your account, you're going to have a very different reaction to somebody charging you 20 bucks. Okay? And so, remember, this is always like balancing an account. You always have to deal with the number of valence electrons you have available, and you have to have that exact number accounted for. You can never have a different number at the end. So, carbon is in group 4. That means carbon has 4 valence electrons. My goodness, I am very, very bad at writing with this. But that's okay. You can tell that's 4 because I said it was 4. All right, now, hydrogen is in group 1. And so that means hydrogen has 1 valence electron per hydrogen atom. But remember, this number right here, CH4, that 4 means that there are 4 hydrogens. That means that you have 4 hydrogens. So this is going to be times 4. So 4 times 1, because remember, each hydrogen has 1 electron. Now, that's going to give you a total of, well, 4 plus 4. So that is 8 electrons. That's still really bad. All right, now, that's 8 electrons that you have to account for. You can't have less, you can't have more when we're done. So remember, you always have to do this step, but there is a shortcut which I will discuss later, okay? But remember, you always have to account for all the valence electrons. You cannot shortchange. You need this number right here, and you need it to be correct. If it is off by even 1 electron, you will not be able to get the Lewis structure out of this. So the next part you're going to do is, well, you need to figure out what's in the center. What's going to be binding everything else? What do you have to write your bonds off of? And so what you're looking for here is the thing that connects the most. The one that can accept the most electrons into it. And so we look here, carbon. If you remember from the previous class, this periodic table, everything wants to be like a noble, right? And there's a very good reason for this, as you should have learned in the previous chapters. And that is that these noble gases, have full orbitals. So remember, every period is an energy level. So when we're going across a period, we're literally filling up all the spaces around it that's for that energy level. We're literally filling up all of those orbitals. And so at neon, we have all our orbitals here filled up. Okay? If you want to put another electron, you have to go up here to sodium. And again, when we get through here, we filled up all of our orbitals again. And so if we want to put another electron, we have to go all the way up to a new energy level, like going all the way up to a new floor. And so when you go from carbon, you fill it up, you're going to gain another electron, another electron, another electron, and it will be full once you've gained 4 more electrons. That's 1, 2, 3, 4. Thus, it is isoelectronic, or another way of saying it would be like neon. All right, so we look here, carbon needs 4 things to be the same as a noble, right? Hydrogen only needs 1. There's only 1 step to go to helium. And so the thing that needs to be in the middle is going to be carbon, because it needs 4 steps. And so we put carbon in the middle. All right, now the next thing we're going to do is we're going to bond. So we're going to put single bonds going off of the carbon to all the other stuff that we need to write out, all these other atoms. And so we have 4 hydrogen atoms that we have not accounted for. And so we will write in 4 hydrogen atoms with single bonds to the carbon. Now keep in mind, this is one of the simplest things you can do for Lewis structure. CH4 is the absolute entry level, and it's one of the most important ones you'll see. So it's very, very easy. Many of you may have realized already, oh, we're done, actually. But let's do the rest of the steps, at least as far as we can go. So remember that we talked about how we had 8 electrons before. Well, we have to account for those 8 electrons in this molecule. And so we look here. Each of these bonds is going to be 2 electrons. So we have 2 electrons in that bond right there. That bond is another 2 electrons. So that's 2, 4, 6, 8. We have 8 electrons accounted for. Now, that means that this hydrogen right here, it is involved with that bond. So that means that hydrogen is associated with 2 electrons. Remember, how many electrons does the hydrogen need filled up? 1, 2. So you see that hydrogen right there is actually full. It's like a noble right now. That's why we're doing the bonding. So carbon needs 8 electrons to fill it up. That's 2, 4, 6, 8. See there? We have 8. How can we tell this? Well, it is in this period 2, which has 8 electrons possible to fill it up. That's what that 8 is right there. All right, now, so carbon needs 8 electrons filled up. We currently have 2, 4, 6, 8 electrons that are associated with this carbon in bonds. All right, so what if we had a double bond? A double bond would be 2 for that bond right there, and another 2 for that bond. So that would be 2, 4 electrons. A triple bond, well, you probably guessed it. 2, 4, 6 electrons. Great. Excellent. All right. So I know that your book and many other books and people will say that you can put 2 dots to represent a bond, like so. Don't do it. All right? First off, it just does not work well once you start getting more electrons. So if we ended up getting things like lone pairs, which are a pair of electrons that are not in a bond, we're going to quickly see that these start blurring together. And all it does and has ever done is cause people problems. I promise you, if you sit there and start just putting dots for your bonds, you are almost assured to mess it up sometime and get a problem wrong. I have seen hundreds of people put dots for their bonds, then within seconds of drawing it, tell me the wrong stuff from their drawing that they drew with dots. You just can't keep track of it. Okay? Doesn't work out. So draw lines for bonds. Dots will always represent the electrons, just like we had talked about in the previous demonstrations. Now, that's CH4. That one's really, really simple. I'm going to get rid of this, and then we're going to try something a little harder.